So
This
we'll be
conference will now be recorded.
today we'll discuss both the collections as well as multi-threading. So which is also very important concepts when it comes to your like high level when you go with the advanced like learning or with the other cases as well. Okay, I'm just sharing the screen. So first we'll go with the collections, then we'll be going with the multi-threading as well. So I hope you can able to see the screen, right? Okay. Mm, just making sure recording was happening. So like have you heard about what is an array? Like had an idea what is an array, and so we'll go with a collection. So before having a concept of collections in Java, in C also you have a concept of an array, right? So what's an array is nothing but when you want to store similar elements, right? So into a place, so you take that as an array. For example, you have a students, right? You have the student roll number as well as student I names, right? So when it comes to the rule number, what is the type of the what will be the data type of a rule number? It will be the integer, right? So I have 100 students in my class. In that case, I cannot able to declare 100 times that same int a, int b, int student one, int student three, like that, right? So what I can do, I can group the similar data type items. So into one kind of a structure, nothing but an array, right? Similarly, if you see, name is kind of a string kind of data type, right? So you group those into one kind of an array, right? But so and you will be not it will be useful, like it will be helpful instead of declaring all the items 100 times, right? So but there are some disadvantage with an array, so that we just overcome with the collections concept. I think you can able to see the slides. So I don't want to read the slide one by one, but you can, I'll just try to tell you overall, but you can just go through that points, then you'll get like bit better understanding on it. So you see the first point, right? So arrays are fixed in size, and since we cannot, once you created an array, you cannot able to decrease or an increase an array. So when it comes to collections, they are growable in nature. So why? What is the disadvantage of making? You have advantages and disadvantages, but as of now, we are discussing that disadvantages of an array and why you came with the collections. It is not that you always choose a collection, but there are situations you need to choose the collections and arrays, but here we are discussing why you need to go for a collections over an arrays, right? So when it comes to an array, arrays are fixed in size, right? So what does the fixed in size mean? So for example, I have 100 students in a class, right? So I just declared an array with size of 100, right? So for example, the next day there is one more student came to the class, and the size it will be so the students count increases, right? So it will be 101. So in this case, what I should be doing, I should be I should have an option to increase that array, right? So which is not possible. Again, I need to create an array with 101, right? So when there is a case of dynamic case, you cannot able to decide that array size. So once the array size is fixed, you cannot increase or decrease. So if you make it as a very larger size, for example, I'll make an array with 1000, right? Assume that there are only 100 students came, then what happens? Then again the 900 is wastage of space, right? So this is kind of a disadvantage in case of an array. But when it comes to collection, they are, the name says it's they are global in nature. For example, if you just say take an array of size 100, if there is one not 100 one more student came, you just try to increase that array, that size, right? So that's the reason they call it as they are in global in nature. And the arrays hold primitive types, but can be holding the primitive as well as object types. So in Java there are like primitive types as well as object types, right? So what is a primitive types? Like integer, float, you call them as primitive types. Like what is our object type? Like for example student, right? Student, employee. So they are not the predefined things in Java, right? So you are creating student, class, object, address. All these are nothing but the objects that you are creating for your use cases, right? So you cannot hold this type of objects in case of an array, right? I just want employees as an array. Like I have 100 employees, I just want that 100 employees as an array. I cannot able to hold with array. In that case I need to go with collections, because your array cannot hold object types, it cannot hold only the primitive types. And performance point of view, arrays are faster than collection. Performance point of view, they are slower. But you need to decide, right? Based on your requirement, you want to compromise for performance, and you have this cases, then you go with the collections. But my case is like I know what is my fixed size. I will not have any object classes. So for sure, then you are very sure about the case, you can able to go with an array, because arrays are faster in performance. Then you get better understanding why arrays are slower and why collections are little sorry, why arrays are faster in performance and why collections is slower. With some of the few examples, if you go, then we'll be getting more idea. And arrays hold homogeneous, and collections hold this heterogeneous as well as homogeneous. I think this point will also be clear to you, right? What do you mean by homogeneous? For example, I have an array, and I just had a integer type, right? So data type of int. So for that same array, I cannot able to add string type. I cannot able to add float type, data type. So it is only with unique. If I declare an array with int, I can add only integer objects. I cannot add string objects. I cannot add character things to it. But when it comes to the collections, they are heterogeneous. It means I'll just declare an array. You want string, you can add. If you want integer, you can add. So if you want object type also, you can add it, right? So but there are some generic concepts we have, but we'll discuss. But in general nature, it will not do any restriction, right? You declare an array, you it will allow you to add anything. So memory point of view, arrays are recommended, but sorry, memory point of view, arrays are not recommended, but collections were recommended. So you get this things more clear. And this arrays will not be having any data structure, right? But your collections will have a data structure, right? So can anyone define what is a data structure? Like if anyone from CSC or any idea what is a data structure, why you need this data structure? I do not say that to understand the collection, you need to understand the data structure, but you should have a basic understanding what is a data and what is that data structure.
Okay, let me try.
Yes, that's great actually, please.
Yeah, data structure is there are methods or ways of organizing data for easy accessing. We have different
Yes,
ways of that. You have
yes,
different types of data structures depending on the design
mm,
or the approach.
ye- yes, exactly. That's what right actually. So here the data is something where you organize the data. Like when you have huge amount of data, right? So you need to put it in a way, in a structured way. So that is the reason you will be getting a your required output, right? So like when you have lakhs and crores of data, right? And I just want that data from that lakhs, I just want one particular element to get picked, right? So if you it is in a not organized way, so how you get it, right? So for example, you have some numbers, you keep it in ascending order, you keep it in descending order. It is also a kind of structure that you're maintaining for a data. All right. So similarly, you have different kinds of data structures like queue, array list, linked list. So when you have huge amount of data, how you keep it and how you do the manipulations. So that is all about your data structures. It's like a huge concept, but in a simple words, like you have huge data and how you place it and how you retrieve the data and how you add the data to it. Right. All this comes in place of data structure. So when in case of collections, you have predefined, like you have like many data structures like array list, linked list, queue, and we will be seeing all this what is that. But in an overall, this is what your collections and an arrays, and why you go for a collection, and what is the disadvantages of an array when it comes to collection. uh, Hope this is clear. I'm moving forward, and please stop me whenever you feel not clear with the things. Okay. So I think we discussed what is an interface, right? So interface is something where you have an abstract methods. There is a classes which implements that interface will be providing the logic for that, right? Similarly, these are all are nothing but predefined classes and predefined interfaces in your collection. Right, collection is something different framework. It's like a concept actually, how you have exception handling, multi-threading, and like in previous sessions we have just discussed what is oops concepts, right? Like encapsulation, these things. Now we are entering into a different module in Java, that is your collections. So in collections you have a collection interface. So this interface is at a high end, and it is again classified into three types, like list, set, and queue. Right, so it, I'm not going the big picture, but it's like a overall thing. So again, this all are nothing but the interfaces. So this is the child interface and this is the parent interface. An interface can able to be extended and another interface, right? So I have a collection, so this interface will be extended by set, list, and queue. These are nothing but all are, I can consider tell as nothing but the childs of your collection, right? Again, this interface will have an implementation like array list, vector, and linked list. All these are nothing but your classes. List is nothing but your interface. These are nothing but your classes. For a set, an interface, you have these classes: hash set, sorted set. These all are written in Java itself. So Java has provided all these classes and the things for you. Is someone want to ask something? Okay, you can see this arrow says it's an implementation, and this dark arrow says an extends, right? So what I can do for an interface, I can do the implements and extends, right? So this is nothing but interface. So that is the reason interface can be extended by another interface. This is also an interface which extends another interface. This is also an interface which extends your collection interface, right? And for an interface which is like your list, you have some predefined methods, right? So all that methods will be implemented by your array list as well as your vector. Is this clear, or you want me to show little more with the diagram? Okay, I'm just telling you. So you have a collection. This is an interface. Okay. So all these are predefined in Java. Okay. Assume that interface is having some methods, right? M1, M2. It is not M1, M2. I'm just assuming it. Okay. So it will have different methods. Okay. I can just say, okay, uh, void add and remove. Just examples with the different methods. Okay. And I have an array list. Like I have a list, right? So I have a list which extends your collection. Now collection is the parent and list is an child. So this is how this list is also an interface. It is also it is not also not having the abstract methods, right? It is also an interface. Sorry, it is also not having an normal methods, right? So as I told, whatever the parent properties will be getting to a child, right? Whatever the properties of your collection will be get to your list, right? For example, I'll have one more method called some void m1 over here, some other method, something, right? So, and for example, I have a class called array list, which not extends, which implements your list interface. So what is the case when a class implements? It should override all its parent methods, right? Abstract methods. In this case, what are the, you have three abstract methods, two abstract methods from the parent class and one abstract method. So from m1, that is from the list child class. So it means list indirectly has three methods. If you see list, you can see only one method, but indirectly your list is having three methods because two are from parent and one is its own method. Now your array list need to override all these three methods. What are the three methods? Like your add. I think you are understanding why I need to do overriding, because it's an implementation. You need to provide override add, and you need to override this remove. There are many methods. This is not, I'm just taking an examples. Okay. And that m1. Okay. Basically there will be no m1 method, but is an example I'm telling you. Void m1. So all these three methods has to be implemented in another list. Same way, this is a simple example that I have given for list, and the same way happens for vector link list like this. Is this tree clear?
Yes, Surya, but I think only
Hmm.
examples can explain which are the things which extends and which are the things which implements.
Can you please repeat, pardon? I didn't get you. What, only the examples?
Yeah, okay. The tree is
Hmm.
clear, but there are so
Hmm.
many things here. Few are extending, few are implementing, right?
Yes,
So
exactly.
just
Hmm.
just with this tree, we cannot know what are those. So if there are examples, we'll know it better.
Oh, yes, there are many methods actually. I'm not going to tell with the methods. So it's like an overall tree. So as you go on, I'll be giving you an examples also. You'll get more idea. Yes. Hmm.
Sure, Surya. Yeah, sure.
Okay. And so first, as a collection is a parent, and we have two things, right? List and set. So both are nothing but interfaces. First, we'll go with this overall with this two, and we go with other things on upcoming sessions. Or okay, you can just, the major difference is nothing but your list and set. So both are nothing but the interfaces, but you can see there is some differences, right? So here list can able to store the duplicates, but your set do not allow the duplicates. And you can just go through these points and you'll be more clear actually. Okay, you come here. So both list and set are the childs of your collection, right? And this list will have the implementations, your set will have the implementations. So your list will have the implementation of array list, vector, linked list. Your set will have the implementation of hash set, sorted set, linked hash set. All are nothing but your implementation. So whatever the properties for the list is having, the properties will be same for its child, right? So that is I was trying to tell you in the beginning also, right? For whatever the parent properties, for sure we'll be getting to the child may can have an extra properties, right? In general scenario, like as we are the human beings also, user can just take it, right? So we may get the like the whatever the our parents characters or parents resemblance, we'll be getting it. We'll have our own identity, but for sure we'll have the parent characteristics. In the same way, in Java concept also, whenever there is a child, for sure the child will have the parent properties. It means whatever the parent behavior will be the same with the child behavior, and child may can have the extra methods. Same way, whatever the behaviors that I told for the list, it will be applicable for the implementation classes of it. Whatever the properties for a set, it is applicable for all the implementation classes of it. So you can see array list, linked list, vector are nothing but the implementation class of your list. Someone want to ask something? Okay. So here you can see it stores the duplicate values, but it does not store the duplicate values. And these are the implementation classes like linked list, vector, and these are the implementation classes of it. And you use this list iterator to travel to that. And like why you need this? These are nothing but your cursors. List iterator will like have a group of objects, right? I just
Hello,
want to
sir.
iterate it. Yes.
Yeah. Sorry, it's not actually part of this class, but I want to ask if there will be other extended class after this 10 days straight this class.
Uh,
Will there,
I was
will
not.
there be
Can you,
provision?
Charles? I was not clear with your question. Can you please repeat it?
Will there be a provision for other training after this 10 days class?
Okay, you are asking any trainings after this 10 days classes.
Yes, as in to get proper knowledge, like to build projects, to learn other things apart from this basic
Yes,
training.
yes. Also, this is a basic like overview of what Java and all that. For sure, we'll be having a training after this, and we'll get to know like after once we finish this trainings, we'll let you know that details, Charles, for sure.
Okay,
What are the
okay,
upcoming sessions? And for sure, I think you are will be you are there in the group, right? So we'll post that things.
okay, all right.
Mm,
Thank you.
thank you. Mm, okay, so first we'll discuss what in a list, this array list, right? So we come with array list. Okay, so as I told, right, what are the properties of your list will be there for your array list, because it's a child. Your list is a array list is a child of your list. So what a list can contain duplicates, right? So you can see here, stores duplicate values. The same property was discussed, like it can store, it can contain the duplicate values. So it means for an array list, I can add same kind of elements, right? One or Rajesh. When it comes to the string, I can able to add same kind of elements, and it will store in insertion order, right? If I add 100 elements, it is going to store it in a particular how you insert, the output will be in that particular order. And it is non-synchronized. So it comes with what is non-synchronized with multi-threadings. Once we discuss this concept, you'll get an idea what is this non-synchronized and multi-threading things. And array list allows random access and are at the index level. So if you see the structure, you'll understand why this point, what is this point actually. It is little bit slower than linked list because of shifting. And this point also, these 2 points will be, you will be clear when you see the structure, how an array, how the data stores in array list and how the data stores in a linked list. So then you get these points very clear. So we'll just see how the data gets stored in an array list and what is the structure of an array list. It is similar to your array. I think some got hacked. Okay, this is how you do add or remove an element in an array list. Okay, so for example, this is an array. right? I just want to store this many number of numbers like 11, 0, 5, this many numbers in an array, right? How I'll get stored, it just how you add it, it's getting stored in this way, right? So but after adding these elements, right, I just want to adding an element at 55th at the fourth position, right? So you want to add 55 at this fourth position. Already you have at fourth position, what is the element you have? It is nothing but 14 or something, right? So sorry, at the index 3, not at fourth position, at the index 3. So 0, 1, 2, 3. So at this index you want to add which element? 55, right? Already there is a 5 element which is sitting over here, right? So when you want to add it, so what you need to do, you need to do the shifting, right? Shifting, right? So this much shifting you need to do, right, until the end. So your ninth element will go to the, like, the element in the ninth index will go to the 10th, right? So for example, you have the list of 100 size, right? I just want to add the element at this position. So how many shifting I need to do, right? 100 minus that position, right? 100 minus, for example, at the third position, it may be like 96 positions I need to do that shifting, right? So after doing that shifting, this is how you're restructured, this is how your data gets restructured. Before, at third index you have element 5, right? So after shifting at fifth, at third index you have an element 55. Okay, so this is how the, like, when you want to do the insertion is little difficult in the sense it will take a light, it will take the time. So similarly, when you want to do the removal, the same operation. So I just want to do the removal at this position. So it, whenever you want to do the removing, you need to do that left shifting. Here it is a right shifting, right? So if you want at the 99th index or like that, right? So again, that shifting will get increased, and it will be your time consuming. And again, after removing, it will be again, this is how the data gets rearranged. But assume that you just want an object to get, like, you want retrieval operation, right? So for example, I just want the retrieval at the element at first index. Then what happens, you just pass that get and that element, so it will get it, you will get that element. In the same way, you want to get the element at some 100th index or 10th index, right? So you just pass that get that index value, you will get that element. Here in this case, you do not have the dependency with other elements, irrespective, right? If you are you want to get the element in the middle index, or you want to get the element in the, like, I'm talking about, I just, this is not your updation operation, right? Like storing the data. When you want to retrieve the data, right, when you want to retrieve the data is very easy in case of an array list, because retrieval do not had any dependency with the, it's like a previous elements or further elements, right? So that is the reason your retrieval is faster. As a structure, you can see, you will understand, right, why the retrieval is faster and why the updation is slower. Okay, so I'll just give with an example also. So I'm just trying to repeat it again. So you have an array list, and in an array list, the data gets stored in kind of an array, right? This is how your data gets stored in an array list. So for example, I just want to add 10 elements. So like this, the 10 indexes will be created. 100 elements, 100 indexes will be created. Like for every like you have an index, so it is specify which element you are at, right? So it will always start with 0. If I want to add 10 elements, you will end up with 9 indexes. If I want to store 100 elements, you'll end up with 99 index. Your 99th index, your last element gets stored. This is how the storage of integer. Similarly, you can do the storage of string or object type, but this will never get changed. So but the case here is in the array list, you can see this point. So array list allow random access because array works on index basis. Random access means like retrieval. So retrieval is faster in case of an array list. You can see the structure, right? Retrieval. If I want to retrieve an element at one index, or if I want to retrieve an element at ninth index, right? I'll just pass that index value and I'll get it. So this do not have a dependency, right? If it is first index or with last index, but it is slower in case of an updation, right? So if I just want to add an element in the first or a middle or a last, that transition need to happen. Like you want to add an element at this fourth index or third index, this many shiftings need to happen. So it has a dependency with the previous elements. So that is the reason updation is slower. Updation or removal is slower in case of an your array list. Okay, that's what this point says. An array list manipulation is little bit slower than your linked list. We have not seen the linked list data structure, but by seeing this data structure, you got an idea why your updation is slower in your array list, because of lot of shifting needs to occur if the element is removed from the element. The same thing, it is removed or an addition, right? Generally, what you do for a data, you add a data or you delete a data or you retrieve the data. These are the CURD operations generally you do for any particular kind of data structure data that you have, right?
So I have a question here. Can I ask?
Yes, yes,
So
yes,
in
for sure.
case of in case of updating, when you say shifting happening, so shifting happening automatically, or we need to do some coding on that
No,
for
no,
that?
no, no, nothing. It's a predefined thing. This is like internal structure. So you
Oh,
just write
okay.
a code like add at index, the shifting happens. But internally, there is a code, and Java has given all the things for us. You do it, but internally the performance will be slower, right? So that is what we discuss. We just want to know that why when I say that an array list updation is slower, right? You need to understand why that updation is slower. So internally, this
Yeah,
is the
yeah.
working structure.
Yeah, got it. So even though if we add the element at the end of the index, I mean, right now we are
Mhm.
pushing, right? We are pushing the element. That's why the
Hmm.
performance is slow, right? What happens if
Hmm.
we try to add at the end of the array list? Is it the same case?
Yes, for example, I just want to add at the end, right? So, for example,
Yeah.
you want to add it, you have this element, right? You want to add it at the ninth index, right? This is my end,
Mm-hmm.
right? So, when you want to add it ninth index, what should happen? The element in at ninth index, you have 10. So, where the 10 should go?
Oh
It
yeah.
should go to eighth index, right? So, the element in the eighth index, where one should go, it should go to the seventh, right? So, like left side, the
Got it.
shifting need to happen, right?
Got it. Yeah.
That is the reason again the performance is slower in this case. I'll just try to write a Java example, and like how, as I told, we'll see these points. Whatever I told you, right? Array list shows that in a session order, and it will allow the duplicates that we see it in a programmatical way. And how I'll create an array list, and when I do that, it should satisfy these points, right? So I'm just creating a class called list example. List examples, some class name I'm just creating. For sure I need a main method, right? Now I'll create an array list object. So this is a predefined, like it was given, this is a class which is given by Java. So directly I can able to write array list al equals to some reference variable equals to new array list. How you create an employee object? Similarly, you are creating an array list object, which is given by Java itself. And you show it is showing an error. The error is to import that. So this is present in the package called java.util, which is a predefined given by Java. So in that util, package, you have an array list class. I think we have seen it when you have another other I think we have seen this in public access in access specifiers concepts, right? So when you have another class in some different package, you need to do that import. Similarly, here you have an array list class which is in different package, and that is the reason you are doing an import. And when you want to add an elements to an array list, it has provided a default method called add. So al dot, and I'm writing an object type here. So it is going to give an object type add because I can able to add any type. So I'm adding here to al dot add some 5. Okay, and again I'm trying to repeat that element whatever added, that is 2 again. Okay, al dot add some 6. Okay, and I'm printing this array list. So as per whatever we seen in the slide, right, an array list can contain duplicates, and an array list will maintain the insertion order, right? So in this, as per that, so if I print it, what should be my output? I'm just adding 2526. So what should be my output?
2526.
2526 for sure, because 2 is there, it should allow, because it will allow duplicates, and the it should follow that insertion order, right? The same output I should be getting it if I print it. Run as Java application.
So Surya,
Yes.
the array list uh, has a default add method within it, is it?
Yes,
Okay.
as I told you, right here where I shown you, here collection has an add method, right?
Okay.
So which is an abstract method, so which is implemented by list. So not like a
Hmm.
list is nothing but a child, so it will also have a different like so now when you have take an array list, so it is mandatory to override the parent method, parent abstract method. So for sure
Hmm.
it will override that parent abstract method, and it will do the it add method will have a logic to do the addition. So it is not,
Okay.
you just need like Java people has written that like logic how to perform the addition. What you do, you are just calling that element, right? It is generally
Okay.
if you do not consider this as a predefined class like a normal
Hmm.
class, you have a add method, and when you want to call this method, what you do, you will create this object and you will call this method, and you will pass the parameter, right? Here for an
Hmm.
add method, it is having that parameter. It is not an int type, it is an object type. So if it is an
Okay.
object type, what I can do is I can pass integer, I can pass string, I can pass whatever the value I want, right? Because this is what your dynamic binding, which I told you in the previous session. Like a
Correct.
parent can hold the child objects. In Java, you see this, every class, whatever the class that I take are nothing but the childs of an object. Object class, you have an object class which is of parent for all the classes. If I take a class A, class B, or array list, whatever the class that I define, for sure that is going to be the child of the object class. By default, the implementation will happen. By default, the extents will happen. It means it is not required you to do that extension.
Okay. So we don't
Okay,
have
if
to
I take like
explicitly write
do
the
that
method
extension,
once again. Okay. Or
extends that thing. Hmm.
okay. 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 Fine. Got it.
Because if you see this child list example is there, right? I've just written this list example. So when I just want to make this as a child, what I'll do, extend some class, right? Extend some
Hmm.
class A. Now what happened? This A is a parent and this list example is a child, right? In the same
Hmm.
way, whatever the class that you write, by default, it is the child of the object class in Java. there is an object class in Java which is given by them, like, and you have different object methods. I don't want to discuss that as of now, but by default, this whatever the class that you write is nothing but your child of the object class. So if you write or don't write, by default it is a child of the object class. Why it is a child, why they have given in that way is nothing but it can able to hold anything, right? In this case your array list is also the child of object class. So that is the reason, if I write al dot add, right, you can see what is a parameter. It is accepting an object type. When it is accepting as an object type, you can pass string, you can pass integer, you can pass some your customized object, because object can hold its childs. Is this
Okay.
confusing or clear?
Um,
Little confusing.
Actually, yeah, a little confusing.
Yes. Okay, the thing is, if you go deeper, you get confused. If you just
Yeah, yeah,
nothing
that's
like
why I was
it is
thinking
not
why
like
I asked this question.
no, no. Yes, yes. Even some may also think, because it is not like one day you'll not be getting the things for sure. I'm not your name. Sorry.
Okay. Yuvraj.
Ah, you're right. Sorry, you're right. The thing is, in one day for sure you'll not be getting the things. Like when you do a regular practice and you get it, right? For
Yeah, yeah,
example,
sure.
you understand it, right? So for example,
Hmm.
I just write an array list and you add it and you execute, you are fine, right? But
Hmm.
when you
Hmm.
start questioning, there are a lot of concept here. Why this object
Correct.
is there, and why for an array list, how can I add anything, right? So
Hmm.
generally, if I pass string also, why it is allowing it, right?
Correct. The
So
moment
how
you
this
said
internal working? Uh,
yeah, the moment you said
but
about
it is
extents, everything got confused.
no, no, I don't want to confuse you, but the thing,
Okay.
it is not for sure, it is not going to be coming in one class, right? For sure.
Okay.
Hmm. But try to understand this in exception and sorry, not exception handling, this dynamic binding, these things you'll be when you try to come interlink the things in Java, you feel the things very comfortable and easy actually.
Okay.
And
But
you, when you
some
understand the concept also, you feel very excited. Okay, this is how, why okay, that is the reason they have given this.
okay, so you said something about
Hmm.
the object class, right?
Hmm.
I don't
Yes.
know whether I don't want to you to explain it now, but sometime
For,
later also you can explain what's an
uh,
object
uh,
class.
okay, for sure. Actually, after this is like a free like demo that we are happening. It right for 10 days, or
Hmm.
because I cannot able, whatever the concepts that I have covered. It is just for sure. I cannot have that time limit to explain the things very clearly,
Got it.
right?
Okay, no
So
problem.
what I'm trying to tell is nothing but, after this session, like if you're really interested for Java, like we'll have an announcement, like a long Java batch which you're going to start with the full Java with a full course, right? Where I'll
Yeah,
cover with
sure.
the core Java and advanced things. So we can, if at the time and we'll be getting to notice, then you can able to register there.
Sure, sure, Surya. Yeah, yeah.
Hmm.
Thank you.
Okay, thank you. Fine. Okay, I don't want to go inside, but here this is how you, for an like an array list, you can able to add primitive types as well as nothing but your object type, as well as it is an heterogeneous, right? What do you mean by heterogeneous? This thing gets satisfied, right? Here int is nothing but an integer data type. Here string is nothing but a different kind of data type, right? You can able to add both kind of data type objects to an array list. So if I print, it is going to get the same output. It will not throw any error for me. Sorry, what happening? I was just okay. So it is allowing integer type as well as string type. Okay, there is a generic concept which will not allow. We'll see that later. Okay, and this is how the data now gets stored. You can able to do that assumption, right? I was bad at painting, but I'll try. So this is how internally your data gets stored. at 0 index, and this is at 1 index, and this is at 2 and 3. What are the elements that you are adding? 2, 5, 2, 6, right? So 2 gets stored here, 5 gets stored here, and 2 and 6, right? So this is how your array list: 0 index, 1 index, and 2 index, and 3 index. At 1 index, what is the element that you have? At 5, right? But at 1 index, if I want to add another element, al dot add, so it will provide an option called index and specify that element. So at 1 index, now I want to add 10. Now what will be your after adding this, if I print an array list, what will be your data now? 1, 10, 5, 2, 6, right?
210 to 6.
Mm. So you're adding 10 at the, so your 10 come in the second position. 210 to 5, 2, 6. Again this 5 shifted to, no need to explain, right? Again this 5 shifted to like this, and one more index comes here. This is same how this thing, right? This is how the shifting happens. The no need to worry about that interstructure, but you need to understand why that operation like manipulation is slower in case of your array list. So in case of get retrieval, it will not be the case. So if I want to get an element at the first index, or so what I'll do, al dot get, have a method, and I can pass that index. If you pass it 0 index or 99 index, it will not be, it will be with the same. So now you will be getting what element? You will be getting at the 10. Sorry, 2 index, right? 0, 1, 2. It means third element. You are getting an output as 5. That is the reason. Okay. Hope you are clear how you add an element, how you retrieve it, and how you do manipulation, and why that manipulations like addition and the slower in your case of array list. So when it comes to the linker list, this is how the data gets stored in the linker list. So you see there is a lot of difference in storaging of data. So what I want to store 15, 3, 17, 19. So these are the three elements. I just want to store it in the linker list, right? In array list it is a straightforward, but in linked list it will store in kind of nodes actually. So what do you mean by node? Here a node contains two things. One is nothing but the element, the value of an element that you want to store, and the next no next thing contains the address of the next element, right? For example, as I told, I want to store 15, 3, 17, and 19. So first 15 gets stored, and the next will be the address of the where the next element gets stored. So for every node you will have an address. For this you have an address of 320. For this node you have an address 3600. In a computer everything stores an address, right? Like this. And what is this 3600? Is nothing but address of the next element. What is this 4000? Is nothing but the address of the next element, 17. So 4000. And what is this 440? This is nothing but the address of the next element. After 17, what is the next element? You have 19, right? So after 90 element you do not have any value to get stored, so that is the reason it gets stored as a null in the last in the node. So the first node address for the first it's getting stored with head, and the last one will be getting stored in the with null. So in this case this is how the data gets stored, right? And if you want to do an updation, for example how I have a data like storing of is in this example you have just 4 elements, but I have a data of 100 elements. The structure is same, right? And when you want to add the address, when you want to add an element at some particular index or some particular position, right? So here what you do, you just try to shift that nodes, right? I just want to add that address set in between 3 and 17. So what happens? Now I want to add some sixth element. I'm just you just do an assumptions. Okay, I am not drawing it, but please try to do the assumptions. You'll get it. I want to add some element, some 33, right? So what happens? That has address of that 33 in this nothing but in 2000 node, right? Now instead of pointing this to 4000, this will get point to this 2000, and here this 2000 gets pointed to this. I will draw otherwise. This is it's I'm just talking about linker list. Okay, I have a 3 element. Whatever I down write is nothing but address. I have a 5 element which is of 4000 address. I have 6 which is of what, some 5050 address. This is nothing but your data. 3 5 6 are nothing but the data that you want to store, right? A node contains two things. One is data and the next is nothing but the address of the next element. So what is the address of the next element? That is 4000, right? Here it contains 4000. So here what will be the value? Here it will be the 5050. That is nothing but your address.
5050.
Yes, and this is the last element and that will be a null. So this is how your data gets linked in a linked list, right? And in middle of 3 and 5 I want to add some 8 element. Okay, data is 8 and I have some I'll not specify that address as of now. So here the address of this will be, assume that 6060. Address of this node is 6060. In between 3 and 5, if I want to add this address, what I should be doing it, I should remove this connecting node and this should point to here, right? So whenever this is pointing here, what happens? It should not be 4000. What will be here? The value will be 6050.
6060.
Sorry, six. Thanks for that. 6060. And here, what will after this? I just want that this connection, this to be connected with value 5. So then, what will be the value here?
4000.
4000.
4000. Okay, this is how you just change the node, right? Here you just assume it, this is not your updation, right? Here if you have 100 elements also or 2000 elements also, is there any shifting or is there any, when you do any manipulation, is there any which is any difficulty with other elements? You just trying to manipulate only the two particular nodes. You are not worried about the number like 100 or elements. There is no shifting and there is no dependency with other objects, right? So this is how the manipulation is easy, not in the easy in the sense like faster in case of your linked list, right? But the vice versa, the retrieval is little slower because when you want to get the element, it is not so easy. You need to get the address, you need to like what is the previous node, like all this information, and like retrieval is little slower or little complex when compared to an array list, right? So when a data stored in this case in this way, it is very faster. By seeing this, I will pass index, I'll get element. I seal this, I'll pass that and I'll get. But in this case, you cannot pass that address and you get it. Like you need to know, have a knowledge on the previous nodes, and it is just a single list. And in case of double linked list, you'll have two nodes actually, like the previous element address and the pass, like the next element address. So in this case, it is not so easy retrieval operation. It's not like retrieval is not faster, but updation is faster because you do not have the link with the, when the number is greater also, you do not have the link with the things device objects. Is this clear? uh, are you clear like why the updation is faster in linked list and why the retrieval is slower, and why, and it's vice, like vice versa?
Yeah, yeah.
Okay, thank you. And but the characteristics is, it will it differ for an array list and linked list, a part of updation retrieval? What are the, what I mean by the characters is, is nothing but the duplication, like allowing the duplication, and like storing the insertion order. So that will be differ for an array list and linked list, or it will be the same? Yes or no, please? My like you understood, we just discussed about an array list and linked list. What we concluded is nothing but array list is faster in retrieval, slower in updation. Linked list is slower in retrieval, faster in updation. This is what we concluded, right? But I'm asking, in array list, and we just discussed, in array list the, it will store the insertion and your array list will allow the duplicates. So these are the things that we discussed, and we see with an, we have saw, we saw with an example also. I'm just asking whether these two characters, like storing in an insertion and like allowing duplicates, will it be differ for analyst, or it will be the, sorry, it will it be differ for linked list, or it will be the same?
Same, I guess.
It will be same because
No.
both are lists.
Yeah. Yeah.
Yes, yes, no need to guess. It is for sure, it is same because
Yeah.
uh, both are nothing but the childs of your list.
Yeah.
This is the first point that we seen, right? Or with the diagram, you can just see array list and linked list are nothing but the childs. What these are nothing but storing it in insertion, like no, allowing duplicates and following insertion order is the characters of your list. So the parent characters will come for all the childs.
And they both have same insertion order, right?
Yes, yes,
Okay.
exactly. So whatever I done in, if I'm making with the array list also, sorry, linked list also will not change the output. If you want, I'm just showing it. Instead of taking an array list, I'm just trying to take a linked list. It is asking for the import. So you can see the output is same 210. So it is allowing the duplicates two, and it is it is following that insertion order, right? And there's other, this is how this is how you create an object. And there's one more thing, how you create an object. This is how your static binding, and there is one more dynamic binding. Can someone tell what is this dynamic binding? List al new equals to new array list. This is what we discussed in the previous session. So list is a parent of both array list and linked list. So at left side, if I hold with parent, I can create an array list object as well as a linked list object. It will not show me an error. So parent can hold both, any child object, array list object or linked list object. If a parent has an implement extension of 10 classes, 10 objects I can create. So your parent can hold the child object. So that is the reason you can able to do it. But in this case, you cannot do. There is no relationship, direct relationship between linked list and array list. So I have a reference of a linked list at left side. If I'm trying to create an array list object, it throws me an error. So this is what your dynamic binding and this is what your static binding. Hope if are clear with yesterday's session, this will also be getting understand to you. Mm. And this is what your linked list, array list, and how the data structures is like a sliding. And you have a vector also, which is a child of the list, but it is a legacy one. Legacy is nothing but the old one, and your it has vector is thread safe actually. So what is this thread safe and these things? Once we discuss this multi-threading, you get understanding of this. You have, as I told you, cursors, right? So what is a cursor is nothing but you are adding these elements, right? Like this many elements, but I just want to get an element like I just want for example, you just add an employee objects to an list, and I just want to get an employee with some name called Rajesh or with some Rahul. Then what I need to do, I need to iterate that and I need to check which name is equals to Rahul, right? For example, you just added a list like hello Java, like .NET com to an list, right? And I want to get the position where the Java is stored. I just want to get the position, or I just want to break the loop when dot comes, right? Then what I do, you will iterate to the list, right? So for that you have a cursor, so you can just see list dot iterator, and it is going to iterate the list one by one. It is going to has next. It is going to tell you whether the elements is there in the list or not. Iterate dot next will get you the value. So first it will get the hello. It is like how the while loop works. Until it gets false, it is going to iterate it, right? So until the elements become zero, your while loop iterates it, and next always gets the what is your current element. First it will get Java hello. If you get Java, next this latte blogspot, like all this, and when you get an element you can just do that manipulations and all this. So for that you have cursors like enumeration iterator and list iterators. So there are some differences between them. You have similarly with a list you have seen, right? Then you have a set. So do you want me to stop or continue? Actually it is 10:03. So you wish.
I think you can better stop, Surya.
Oh fine. Okay, fine, I'll just, we should
Yeah,
follow the time.
because yeah, following the time is one,
Uh,
and
yes.
too much of information to process.
Okay, okay, but please go through the recordings for sure. And
Yeah,
mm,
yeah.
but I'm just
Thank
tell
you.
like for sure like with all this class also you're not going to, for sure you may have confusions, but try to understand the things and let us know any queries. Let me know any queries. Okay.
Yeah, yeah, sure.
Okay. Thank you. Thank you all.